When finding the prime factorization of a number, what you are essentially doing is breaking down that number into a string of factors that you can multiply together in order to equal that number. What is unique and especially important is that all of the factors in that ultimate string must be prime numbers. A very common strategy in order to do this would be to create a factor tree. So let's imagine, for example, that I gave you the number 40. And let's say that we wanted to find the prime factorization of 40. What we would do is we would draw that factor tree. First, we're going to start out with two numbers that will multiply together to get 40. You can pick any two. If you and a friend were solving this same problem and you picked one set of factors and another friend picked another, your trees may look different, but your ultimate answer will be the same. So I'm going to choose 5 and 8. You could have chosen 2 and 20, you could have chosen 10 and 4, any of those would be possible. In choosing 5 and 8, what we can see is I'm starting out with 5, which is a prime number, and ultimately I want all prime numbers, so I'm going to circle 5. That's going to be a number that we're not going to touch at this point. That's already a prime number, and we know it's a factor, so we're going to leave that alone. However, 8 is a composite number. We need to break 8 down because we need to get that broken down into prime numbers since our ultimate goal is to get all prime numbers. So we're going to break 8 into 2 and 4. And now we see 2 is a prime number. So we're going to circle 2. We're done with 2. We can leave that alone. And now we're going to try and break down the 4. The 4 is composite, so we're going to break that. And we're going to break that down into 2 times 2. I'm going to circle both of those 2's because they're prime numbers. And now you can see that our ultimate result, we have broken this down into all prime numbers. I like to put the numbers in order from least to greatest. So what I'm going to do is I'm going to put the prime factorization down as 2 times 2 times 2 times 5. And you'll notice if you multiply 2 times 2 is 4, times 2 is 8, times 5 is 40. So this is our string of factors, all of which are prime numbers, that equals our original number 40. So when we multiply this out, it's a bunch of prime numbers multiplied together to get to 40. Since math people can like to do things shorthand, what we often do is we'll write our prime factorization with exponents. So we have 1, 2, 3 2's. Instead of writing 2 times 2 times 2, we can write 2 to the 3rd power, which indicates that we're multiplying 2 3 different times, times 5. And this here is the way that we can write our prime factorization with exponents. It's a shorthand way, and it's an easier way to quickly look and see that we had 3 2's and 1 5 that make up our prime factorization. So anytime that you have to find a prime factorization of a number, you can use this factor tree method in order to help you to get it.